Okay, so we introduced the NCS 500 series back in 2018 at Mobile World Congress in Barcelona. And why Barcelona? Why MWC? Because the products were introduced primarily focused on service provider, mobile backhaul networks, being 5G ready, being cost optimized, being carrier grade. But especially the XR routers are highly universal, highly feature-rich routers to be used not only in service provider networks. The part of the series, which the NCS stands for Network Convergence System, is NCS 520 on the left, which is not iOS XR at all. It runs iOS XC. It's primarily service provider access switch and NIT with some especially L2 and just some limited L3 feature set. I'm going to talk in this session about NCS 540, the fixed 1RU routers running iOS XR, and NCS 560, modular, two different modular chassis, again running iOS XR. We started shipping NCS 540 in 2018, and then and the modular 560 series came. Up to date, we shipped around 50,000 NCS 540s to the customers worldwide, to all verticals. Okay, the 540, 560 routers running as XR are actually in a bigger family that we call DNX portfolio of routers, because we, as a base MPU, we use Broadcom Strata DNX MPUs inside. So not just 540 and 560, but also NCS 5500 and recently introduced 5700. They do share the same features and same architecture. So we are leveraging the development across the DNX portfolio. Okay, we still keep our say flagship product ASR 9K and recently introduced Cisco 8000 as a core routers or a high scale edge routers. But DNX portfolio really focuses on say density, high performance, low power consumption, and cost. All right, so across the iOS XR routers, the routers run on iOS XR. That's the carrier class networking operating system we introduced back in 2004 for CRS, or at the same time GSR, so XR 12K routers. And we evolved it over time to be really super scalable, super carrier class networking OS with all the modern tools. So now it runs on Linux. We are using Linux infrastructure. We are using RPMs for packages for protocols. So basically, it's simple, modern, and trustworthy system. So we basically, for the packages, you can choose which protocols you want to load in the router in order to save some resources, because you may run, and it's supported across the portfolio, you may run third-party applications on directly in these routers and really use the networking interfaces. One of the key developments past couple of years is around trustworthy, around security, and these are actually the most secure routers on the market right now. We actually built a specialized Trust Anchor hardware module, which has a lot of, let's say, security features. It provides highly encrypted secure storage for credentials, and actually provides the infrastructure for verification that your router, which you purchase, is really the one manufactured for Cisco, and it's running only Cisco iOS XR. It's not counterfeit, and also the trust is not maintained just during the secure boot, but also when the router is running, we check regularly if there is no malware somehow injected in the code, And actually, we have some visualization tool as well. All right, so use cases for NCS 500 series. So yes, as I mentioned, we primarily focused on service providers, especially mobile backhaul or X-haul for front-haul, mid-haul. But in general, carry Ethernet, and also, let's say, use cases are cable, remote PHY, aggregation, access, and FTTX. You can see by 540, 560 there, of course, like in the core, you can see like that we are having the mentioned ASR 9900 and Cisco 8000 as well. On the other side, so for enterprises, and we do have large number of 540 customers and 560 customers even today. So the use cases are across the verticals, so public sector with some federal state networks, rural broadband, university and education networks, smart cities, utilities, transportation, so railways, highways, all the, let's say, migration from SDH, PDH world. For enterprises as a wide area network router, including some light peering applications. So use cases for everybody. The primary design where we are actually focusing our service provider portfolio on technologies and solutions is around converged SDN transport, how we call it. And it's because we are Cisco, we are focusing on MPLS. But now it's a segment, mainly segment routing extension to MPLS and moving forward with SRv6. So again, these routers, NCS 540, 560, they are fully incorporated into the end-to-end strategy and solution with SRv6 and services using BGP-based L3 VPNs or L2 VPNs, of course, with EVPN as an option. With that, with 540 fixed platform, we can really do iOS XR end-to-end. We can also integrate our, let's say, older iOS XE platforms, 900 series. And we can run up to 100 VD to cell site, for example, to access. All right. So first, let me cover quickly NCS 560, and then we will focus more on 540. So 560 started shipping in 2019 with 2 chassis, 7RU chassis with 16 interface modules and 4RU chassis with 6 interface modules. So the both routers are, you can have 2 route switch processor inside. So that's actually the only system in the DNX portfolio where you can get full ISSU in software service upgrade for upgrading the iOS XR. It's really sub 50 millisecond upgrades. So it runs, again, as mentioned, Broadcom NPU. It's 800 gig total capacity. It's designed to run in iTemp environment, so -40 to +65 degrees Celsius. And it has, of course, because designed for mobile operators, it has a lot of timing capabilities, timing interfaces, timing features. We provide actually options for like different airflows, like by default it's side to side, but there are options how to make it front to back airflow. Airflow is sometimes very important in data centers or some, say, remote locations. We do have 2 different RSP4s. It's called RSP4 because before we have RSP3 hosted and RSP2, of course, hosted in ASR 900 series. And actually, if you look at the 7RU system, is the same as ASR 907. So we took ASR 907, built RSP4, and now it runs iOS XR, not XE, and we call it NCS 560. These are, let's say, single chip, single MPU RSPs. The MPU is dual core. It's 800 Gbps or 720 Mbps. And the variant with E has external TCAM to store some excessive routes in order to support millions of IPv4, IPv6 routes. It also has high external buffer. So if the internal buffer is not enough to store the packets, then the off-chip buffer of 8 gigabytes takes place, and the packets are stored there before transmitted. But it doesn't have any penalty in latency, or this is really internal high-speed connection between the memory and the MPU. So this is the 560 interface modules portfolio. So the three on the left side, these are shipping today, and we are just starting shipping the bottom left one. So okay, from top left, so it's 8 1 gigis, or you can plug CSFP, so 2 gigis in one SFP, and plus one 10 gigi port on the right. That's the one. Then we have 8 10 gigis. Next module, the next one is 2 by 40/100 gigi QSFP28. And the new one is for integrated DWDM coherent detection inside CFP2 DCO, inside CFP2 form factor. So we call it CFP2 DCO, digital coherent optics. And it can run either like 100 gigi or 200 gigi as a multiplex of two 100 gigis. What's coming next year is, let's say, lighter version, or say cost optimized version of 8 by 10 gigi, and then 2 by 100 gigi QSFP28. But these ports will actually be qualified for QSFP DD, but only 100 gigi. And the DD means, like, from the thermal perspective, we will be able to host the high power consuming ZR plus optics, again, integrated coherent detection inside the transceiver with, of course, tunable wavelengths. And with or without DWDM, you will be able to reach really high distances. Thousands of kilometers over DWDM, or like over 100 kilometers of, let's say, unamplified dark fiber link. The last module on the bottom right side, it's 8 10/25 gigi ports, or it can also run as a 4 by 50 gigi SFP56. 50 gigi SFP56 is a new standard, how the SFPs are evolving. So not only 25 gigi is supported in SFP form factor, but also right now it's a 50 gigi with SFP28, SFP56. Okay, let's start with the NCS 540 family. We have NCS 540 medium, and that's actually, let's review what we have today. But in general, 540 family. So basically, it's the smallest iOS XR router ever. So it's really like, okay, 1 RU, but it's below 30 centimeters deep. It's these are the most cost optimized XR routers ever. And of course, we are also focusing on power consumption, because there are service providers, they are building the networks with hundreds of thousands devices, and every watt in power consumption counts. And all this with thousands of features. So, okay, there are competitors. They also use Broadcom DNX MPUs, but what really matters is the XR and our, let's say, DNX optimization on top to deliver the features, to deliver the architecture. Okay, some of the other highlights. There are a few variants. There are also, of course, many variables what to choose for what. We have different airflow options, side to side, front to back. Of course, it's environmental hardened to support, again, high temperatures. It has a lot of different Ethernet interface options. That's Ethernet only, so no TDM interfaces at all right now. Low latency, since latency is key in next-gen networks, especially 5G. You know, everybody talks about latency, the new super critical services in terms of latency. Yes, we focus on the frequency and time synchronization for, again, especially mobile networks. Some of the models they've integrated GNSS receiver in order to get the synchronization directly from the satellites. Of course, we need to have a rich QoS feature set, including HQoS. Platforms are MEF 3.0 certified. And as mentioned, we can host third-party applications on the routers. The family, the portfolio which we are shipping, and as I mentioned, like already shipped around 50,000 devices. It's like it has 5 members. So we have on the top, we have one with redundant modular power supplies, and the remainings are with fixed power supplies, AC or DC, redundant DC, single AC. They're actually performance-wise 2 variants, 300 gig or 140 gig, and up to, let's say, interface types 1 gig through 10 gig, 25 gig, 40 gig, up to 400 gigs, and all the breakouts possible and supported. Some of our has the GNSS receiver, as I mentioned. They are all, let's say, ready for timing perspective. The 4 variants below, like at bottom, are Class C certified. So this is shipping since last year, or even like the first with modular power supply since 2018. The architecture of the routers is very simple. It's really system on a chip, single NPU, connected directly to the interfaces. But of course, there are some specialties. There are some models, they have 5 chips, and the 5 chips are there to support, for example, RJ45, 10/ like copper gig interfaces, 10/100/1 gig, or RS FEC for 25 gigs. Also, we need for EDC for linear optics, for 10 gig linear optics. And on the PHY, where we have the PHY, we can support MACsec on the SFP28 or QSFP28 ports for speeds 10, 25, 40, 100. So, and now what's new? That's actually the portfolio just coming. This is even smaller. Even it's just 23 centimeters deep. 3 variants. It's always dual AC or dual DC powered with Broadcom UX 64 gig or 120 gig at 125 Mbps with 1 gigabyte packet buffer. First, we introduced ARM CPU. It's not Intel inside. Fans are fixed but redundant. It's again iTemp and side-to-side airflow. As pointed out on the right, we have, which is unique, we have 2 25 gig uplinks on one of the variants. 25 gig is becoming standard on, let's say, for on the server side as well as on the, say, mobile infrastructure side. So, but also used to be can be really used as a cost optimal choice for, you know, for like 10, 40 kilometer, 25 gig distance. So these are in detail the 3 variants, actually all 6, because we have the DC-AC variants. And so we have some not only SFP ports, but also combo ports, so copper or SFP. On the left side, on the 4Z14G, actually, it's quite, it's not that tricky. So the Z in the PIT means 10 gigi, 14 means, the G means 1 gigi, and the Q means 25 gigi. And DA is DCAC. And the X means I-temp, so temperature hardened, and conformal coated in this case. So it's also the PCB is covered by plastic layer to protect in some hot humid conditions. So on the right side, the 8Z16G, it doesn't have combo ports. It has also the copper ports, and it has option for CSFP. So again, you can plug the special SFPs, Gigi SFPs, and they have 2 Gigi ports in one SFP running bidirectional connection. And really the smallest one, it's 6Z, 18G, 610 gigis, 18, 1 gigis, no copper here. But all of them share the same infrastructure interfaces, management, alarm, console port, USB ports, and also they don't have GNSS receiver inside, but they do have all connections needed to connect external GNSS receiver if needed for synchronization. Okay, so to prove these are real photos, not professional yet, but it's coming. So this is from lab, our let's say final prototypes. So it's really ready to be shipped. All right, so now spent some time talking about like what's common for 540 family. Okay, it runs DNX, Broadcom DNX inside, Broadcom Qumran AX, and Qumran UX. So for the existing, which is on the left, it's 300 or 160 Gbps or Mbps we discussed, and Qumran UX is the smaller one for the platforms we are just introducing, 120 gig, 64 gig, 250 Mbps. It's a single core. It has a bit lower scale, of course, but architecture same, features same, sharing with 5500, 560. Okay, DNX architecture, just very quickly, it's a pipeline-based architecture inside the NPU with fabric inside, but with these systems on the chip, the fabric is just hardwired in the ASIC. So the fabric, the cells are there, but doesn't make any purpose. We have some stages in the pipeline on the ingress and egress side. It's highly programmable or configurable. There are databases shared for the NPU core. Packet buffers are on ingress and egress. And as well, there is the external buffer for, it's a minimum 1 gigabyte of buffering shared across all ports. The DNX portfolio is well known to have so-called VOQ only architecture, so virtual output queuing. So actually all queuing is done on ingress, where the ingress scheduler asks the egress, hey, give me credit, and I need to send some traffic. So if there is a bandwidth available, egress scheduler gives the credit and the packets are dequeued and sent to egress. Just a note to performance, how we call it, how we treat it, and how it may differ between vendors. So we call it 300 Gbps here, but if we say 300 Gbps, we really mean bidirectionally. So some vendors would call it 600G, but we say, okay, it's 300G. It's, let's say here, the two uplinks sending bidirectional traffic 100 GG at the same time. And then the rest of the ports, again, sending traffic 100 GG in both directions. So this is what we call 300 GG, 300 gig performance. All right, just to, I will not go over all the features, what 540, and this is again a very high level slide showing the feature richness of the routers, but just to stress the fact that we are not just focusing on single use case on just mobile operators, and not just about segment routing, SRv6 and EVPN. It's we actually also like we have spanning tree protocol, for example. We need L2PT protocol. We have LDP pseudo-wires, so all flavors of multicast. So yes, security, but that's obvious. So yes, netconf, yes, SNMP. So really feature rich.
Which type of EVPN, by the way, it is?
Of EVPN?
Symmetric IRB, or I mean, symmetric IRB or asymmetric IRB? Do you remember?
That's okay. That's symmetrical IRB. Yeah.
Yeah. Usually, Cisco supports that.
Yeah. That's okay. That's the what we.
Thank you.
So David, I'm not. I don't spend as much time in the service provider space, so some of this is new to me. So this may be a completely naive question, but I do have one. We've talked a lot about speeds and feeds and different components in the hardware. Is any of this enabling additional services? Are we seeing changes in what's actually capable, or are we just? I mean, is this just like a portfolio update?
Okay, if I'm one of our PMs or like architects and talking about 5G, you would get let's say 2-hour session about augmented reality, remote surgery, and these kind of things. I'm like more on the ground. I'm more like technical guy talking about like realistically about what it can do. But really these things are designed, and for example, the latency of the router is designed to focus on all the marketing buzzwords around 5G and its services. So
sure, and I understand that. Like you can't claim, like, I mean, we could sit here and talk all day about all the things you can do with a network. What I'm saying is, does this provide any additional network capabilities? Are we seeing new features adding to the feature set?
It's more only, let's say, the segment routing SRv6 architecture is more about how to build a network with high scale. And it's primarily, okay, it's not easy to build network with hundreds of thousand devices talking end-to-end, any-to-any. So that's really, SR is about how to build the large networks, how to optimize, how to deliver SLAs with SRTE, for example, latency-based transport and these kind of things.
Correct, but we are a little bit exaggerating it, I think, because even if it's 100,000 devices or more, not all of them talk with each other, right? In the mobile networks or any other fixed-based networks, not any-to-any communication really is happening, but yeah, probably we are a little bit exaggerating. But is it for the large-scale network? Probably SR with MPLS or V6 data plane, even for the smaller scale networks, would be still useful. Yeah. And it is huge discussion and probably time for
really, like, you don't need any-to-any, but you can with the SR. It's possible. Okay. Timing capabilities. it's really like we follow all the industry developments in timing synchronization, all the telecom profile, how to synchronize the network in the best way. And Class C device means, for example, time error of 30 nanoseconds only in one platform. And that's key for the next gen 5G services, as we mentioned. Okay, brief note to Fronthaul. So there's a special category in 540 which is called Fronthaul. And there are two NCS 540s, and they have specialized FPGAs inside, and the FPGAs provide CPRI emulation over packet network, and CPRI is the interface today running between the baseband unit at cell site towards the antenna. So CPRI over radio over Ethernet, which is standardized by IEEE. These routers are built with this capability. These are two variants, 300 or 900 Gbps. The solution which they provide is related to replace the coaxial cables and direct dark fibers between the baseband units, and somehow collocate the baseband units on servers, something called like Cloud RAN, and provide a converged network to run and to run the CPRI over the CPRI for Fronthaul over the packet based infrastructure. Okay, the last addition and what we are building, and this is really something very unique, is 540 large. And that's, again, it's real. This is prototype here. It's Broadcom Qumran 2A, so J2 family, Jericho 2 family, so next second generation of Jericho. 800 Gbps, 6 Mbps, 600 Mbps. Maximum input-output interfaces 1 tera. 2 GB packet buffer. There's Intel CPU. It's again 300 millimeters. Modular power supplies, front to back airflow, fixed fans, iTemp, again, Class C, GNSS receiver inside, planned for Q2 2021. And it has two QSFP56DD, so 400 gig, 2 ports in one RU, in access box, quite huge, and 8 50 gig SFP56 and 24 SFP28. So closer look on this. The 2x400 gig are very, let's say, universal. They support all the speeds from 4x10 to through like 40, 100, 200, 300, 400 gig. And again, all the ports are, the remaining ports are also, they are triple rate, 102550 or 11025. All the ports, as already discussed, and we can do MACsec on the QDD, QSFP56DD ports and SFP56 ports. This one has QSFP-DD. So if you're not familiar, so it's new form factor up to 400 gig. But what's key, you can take your existing QSFP28 transceivers and plug it into QSFP56, and it will still work. The DD is double density, so it has 8 lanes, and the lane is not 25 gig, but 50 gig. So 8 by 50 is 400. So up to 400, all the breakouts possible, and so on. And also, it's ready for the ZR optics for 20 power in single transceiver to support high distances. Okay, that's the portfolio. To summarize, so we have 4 members in 540 family. We will have 4 members in 540 family in 2021. The existing medium up to 300 gig, small, really the smallest, densest, 104 gig, large with the QSFP-DD ports, and the Fronthaul with specialized FPGAs.